beautiful people, and welcome. In today's video, we will be discussing the volume of cones. Now, when I think of cones, I always think of an ice cream cone, like a waffle ice cream cone, but that's just me. All right, disclaimer time. If I make a mistake, I am a human, and that's okay. Just learn from my mistakes so that way you don't make your own. All right, let's get started. So, volume of cones. Here, I pre-drew some cones. One thing you need to know is that the base, let me zoom in here just a little bit because it's pencil and you can't really see it. There it is. The base is a circle. The height has to be perpendicular. So if you watch the video on the volume of pyramids, we kind of discussed the importance of a perpendicular height to the base, okay? So perpendicular means that they meet at a right angle. So the base, which is a circle, and the height must be perpendicular. All right, and then we have this little thing here off to the side. This is what we call your slant height. Okay, I can spell. Three things. Your base is a circle, your height is perpendicular to the base, and then you have your slant height. All right, let's go ahead and identify our volume. So our volume is, trying to find different colors so it stands out a little bit more, 1/3 times your area of the base times the height of your prism or your cone, okay? And I'm going to keep it as the height of the prism because we always say the height of the prism for like a few videos now, but it is the height of the cone, not the slant height, but the actual height. So since we know that the area of the base, well, let's back up a little bit. The base is what? The base is a circle. So what is an area of the base? What is the area of a circle? So the formula can look a little bit different, but it's still exactly the same thing. So here's 1/3 area of the base times the height of the prism or the height of the cone, and that is pi r squared. And again, the only reason I'm saying height of the prism is because that's how we've been saying it for a couple of videos now, but it is the height of the cone. All right, something pretty darn cool. I want to share that with you, something pretty cool. Note, you can't see that. Let me zoom out. There it is. This is your volume formula for your cone. This is your volume formula for your cylinder. So they're pretty much the same. A cylinder has a base that is a circle. A cone has a base that is a circle. So what's really cool is because a cone is 1/3 of the volume of a cylinder, we can actually say that it takes 3 cones to fill 1 cylinder. And that, again, is if we have exact measurements. So if we have the exact measurements for the cone and exact measurements for the cylinder, then it would take 3 cones to fill up 1 cylinder. And that Y is, my OCD is kicking in a little bit. There we go. All right, let's jump into an example. Here is your formulas. Make sure you have that. I, again, recommend thinking bubbles so that way they stand out. All right, example 1. How many fluid ounces of liquid will this cone hold? Again, volume is something a figure or a prism or a cone holds. So if we were to fill all of this up with water, how much volume would that be? So let's start out. What is this? We have a cone. What's the formula? Volume is equal to 1/3 times the area of the base times the height of the cone. Step number 3, volume is equal to 1/3 area of the base, that is pi r squared, times the height of the cone. Step number 4, volume is equal to 1/3. Now, if you don't have to do these steps, you don't do these steps. If you want to jump in, go for it. Okay, pi r squared. Pi, what is the radius? Well, here they tell us that the diameter is 2.4. So we know that the radius should be half of that. So the radius is what? What is half of 2.4? And that is 1.2. And we're going to square that value. And we're going to multiply by the height of the cone. So here it is. Notice that they give you what's on the side. This is what they give you. They give you your slant height. They did not provide what the height, which is perpendicular to the base, is. So I'm going to just connect these two and hopefully you'll be able to see something pretty cool. Guess what we have? Perpendicular means they meet at a right angle. We have a right triangle. So it looks something like this. If you want to flip it over, that's fine. I'm just going to keep it looking the same. So we have the height, which we don't know. We do have the slant height, which is 3.9. And we did find this measure, which is 1.2. And so now we use our trusty calculator to solve. And how do we solve this? We use the Pythagorean theorem. So I'm going to say, again, remember the hypotenuse is always opposite your right angle. So I have, let me change colors. That way it stands out. 1.2 squared plus h squared is equal to 3.9 squared. Now we use our calculator. So 1.2 squared, let's see here if my calculator can cooperate. That is 1.44 h squared. Now we have 3.9 squared, and that is 15.21. I'm going to subtract 1.4 both sides. So h squared is equal to 13.77. So then we're going to square root that. So my height is about 3.71. Now you're going to ask me, how many decimal places do I round to? Here's the thing. Round to 2 decimal places when you absolutely have to round. If you don't have to round, don't round. But if it's a decimal, just round to 2 decimal places. If you are using pi, you must use the pi button or leave it as pi. All right, so now we have our height. So I'm going to bring my height over here, and that's 3.71. So then just use your calculator and finish off the question, the problem. So I have 1/3. Let's use a different pencil. I don't like that one. Times, what is 1.2 squared again? That is 1.44 pi. Again, times 3.71. Here's the thing, this is all multiplication. In a previous video, I said don't combine if it's addition or subtraction. You can combine pi if it's multiplication. So if I were to type this into my calculator, 1/3 times 1.44 pi times 3.71 equals, that gives me a rounded answer of 5.59, and then it goes 455. So I'm going to say 5.595. And what do we have? We have inches cubed. Now, if you want an exact answer, don't multiply pi in. Do 1/3 times 1.44 times 3.71. and you get 1.7808, and then we throw on the pi afterwards. So if you type that in and multiply by pi, you're going to get exactly the same thing. So here it is. Now let's reread the question. Always reread the question before you move on. How many fluid ounces of liquid will this, let me try that again. That was embarrassing. How many fluid ounces of liquid will this cone hold? So we found the volume in inches, but it's asking fluid ounces. So I already have the conversion rate here for you. Here's the thing, if it's ever going to ask you about conversion rates on the homework, you are expected to figure that out on your own, use Google. If it's asking you that on a quiz or a test, I will provide conversions for you. All right, so this is part one. We're not done, so we need to convert. So I'm going to use the rounded. So I have 5.595 inches cubed. I'm going to multiply that by my conversion rate. So whatever I want, so I want fluid ounces, that goes on top. If I want something fluid, that's an L, not a T, 1 inch cubed. So if I want fluid ounces, then I need fluid ounces on top. So that way inches cubed can cross out and I can multiply across to get my final answer. Volume is equal to, let me do this real quick, 5.595 times 0.554. I have 3.1 fluid ounce. Now again, we don't have to cube this because we've already accounted for our units being cubed. Once we convert it, we've converted it out of our cubed units. Here it is. That is your volume. All right, let's go ahead and move on to example number 2. Example number 2. There it is. Let me shift that up. Find the volume of the composite figure. We are jumping right into composite figures here. We're going to do them exactly the same way that we've been doing it. Split them up and see what we have. So what do I have? I have a cone. I have a cylinder. Okay, what is the volume of a cone? Volume of a cone is 1/3 times the area of the base times the height of the cone. Cylinder is area of the base times the height of the cylinder. All right, let's go ahead and you don't have to draw it out. I personally like to draw it out. Here's your cone. Here's your cylinder. What do we have here? What are our measurements? I'm noticing that the bottom, let's start with the cone. The bottom is 16, and so then the height is 19. So we want the area of the base. Here's your base, it's a circle. We know that this is 16. That means our diameter is 16. So what is our radius? Because we want the area of the base. So base area, and what is the base? Base is a circle, so we want pi r squared. So volume is equal to pi r squared times the height of our cone. So what is the radius? 16 divided by 2 is 8. So I have pi times 8 squared times the height of the cylinder, and the height of the cylinder is 19. Big number for me, so I am going to use a calculator. 8 squared is 64. 64 times 19 is 1,216. We still have that pi there. We have pi, and that is our volume for our cylinder. Okay, we're not done because this is a composite figure, so we got to do the same thing for our cone. Draw it out. Since I know the bottom has a diameter of 16, I know that the top also has a diameter of 16 because remember the bases are exactly the same, top and bottom. So then I know for this cone, the diameter is also 16. So then the radius is 8. So then we want to know what the height of the cone is. Again, we want it perpendicular to the base. We don't want the slant height. So how do we figure that out? Well, notice here in our original picture, sorry guys, I want to make sure that you see. Pencil doesn't show up if the background is darker than it is. All right, notice that the height of the cylinder is 19. So what is the height of the cone? So how do we figure that out? 32 minus 19 is 13. So the height of the cone is 13. So let's go ahead and solve for the volume now. 1/3 times the area of the base. Well, what is the base? The base is a circle. How do we find the area of a circle? Pi r squared. So let's plug that in. Area of the base is pi r squared times the height of the cone. So we have 1/3 times pi r, which is 8, squared, times the height of the cone, we said is 13. So we have 1/3 of 64 pi times 13. Let's see if 64 can be divided by 3 evenly. It cannot, so I'm just going to multiply everything out. 64 times 13 divided by 3. Let's see here. It's going to give me a decimal. Let's do decimals. I was trying to get an exact answer, and it's giving me a really large fraction, and I don't like really large fractions, so it's a personal choice of mine right now. So 64 pi times 13 times 1/3, and that gives me 871.268. Since I'm rounding, I'm going to go ahead and round this as well. So I'm doing 1,216 times pi, and that gives me 3,820.18. Are we adding or are we taking away? We are adding, so we're going to add those two volumes together. So my total volume is 4,691. What is our unit of measure? It is millimeters, and it is volume, so we are cubing it. All right, let's move on. Here is one more example for you. We have a cone-shaped hole, so it is, again, a composite figure. So we have a cone and a inside of a cylinder that has been drilled out. I did not give you any units of measure or any measurements, so here it is. That is, and then the diameter is 3.6 centimeters. All right, let's start this again. Same thing, we have a cone, and I'm gonna, for this one, move a little bit faster, and a cylinder. Write out your formulas. And for those of you who are gonna try to not write out your formulas, big mistake. You must write out your formulas because it's going to be very confusing once we not only do volume, we're gonna have to do surface area as well, and formulas will get confusing. So make sure you're writing out your formula so you know exactly what you're doing. Again, I'm just working really quickly here. We know our diameter is 3.6, so divide that by 2, that is 1.8 squared. Our height of the cone, again, perpendicular, here it is, so it's the same height as this, so we have 4.3. I'm going to just block that out so we know. Again, radius was 1.8. Height of the cylinder is 4.3. Using your calculator, go ahead and approximate what the measure is. And I told you I was going to work faster on this one. If this gets too fast, go ahead and slow the video down. I get 58, where is it? 56, excuse me, 8993. And again, this is not my final answer, so I'm going to write as many digits out as possible. So I have 1.8 squared times 4.3 times pi. Oops. And I get 43.7687. So now I'm thinking something went wrong. I know that a cone is 1/3 of a cylinder, but my cone ended up being larger. So now let's do some detective work and figure out what it went wrong. I have my pi, I have my 1.8 squared times 4.3. Okay, so I'm going to retype all of this back into my calculator and see what went wrong. Sometimes you're going to have to do that. Double, triple check your answer. Yeah, much better. Now I get 14. And we can double check. And honestly, if you guys wanted to do it this way, you can. Take the cylinder. We know the cylinder, we know the cone is 1/3 of the cylinder. So if you know the volume of your cylinder, all you have to do is divide by 3 and you get your volume of your cone. Now, ask yourself the question, did we add to the volume or did we remove? So since we have a cone-shaped hole in our cylinder, we are removing that volume. So we're starting out with the volume of our cylinder. We are removing the volume of the cone to get our total volume. And that is I get 29.17. So I'm going to round 29.18. What are our units of measure? Centimeters. What are we trying to find out? Volume. Volume is cubed. All right, guys, that's it for this video. Thank you so much for watching. If I made a mistake, which I did correct it. Very proud of myself. But if there are any other mistakes, definitely let me know, and so that way I can learn from my mistakes. As always, thank you so much for watching. Have a great day, and I'll see you in my next video. Bye.